So as Goran said, I'll speak in English like through the rest of the presentation. To our Russian guests, welcome to the Serbian C++ meetup. No problem. So the topic of today's presentation is the C++ customization points zoo. And the reason why it's a zoo and not a jungle is because we're gonna, look at them from afar. We won't actually look at all of the details, but hopefully we'll see enough in order for us to better understand what are the available customization points in C++. So a little bit about me. I'm a computer science student at the Faculty of Mathematics. I interned at a few places. Generally, I'm interested in high-performance systems and programming language theory and compilers, of course. So to begin, when I was preparing the slides, I saw like a random tweet from like the person quoted Glenn Williams. I think he's like a game developer from the UK. And I'll paraphrase basically what he said is that new programmers like to do some hard stuff in order to basically prove themselves. And I was thinking like whether I'm trying to do that right now. And the answer to that is, maybe a bit, but like as the rest of the code says, it's important that whatever I show you today actually has some kind of use. So the point of my whole presentation is actually for you to go tomorrow and actually implement something in your code base, and not only just see some slides and drink water or whatever. So as Glenn Williams said, he called it the lion tamer syndrome. Since I promised I'll be taming some lions, one of the first examples to understand customization points will be this one. Okay, I think. Okay, you can see it. Basically, customization points are like an abstract concept which represent the interface and the mechanisms for integrating the user's code with a library. So in this particular example, we have our struct lion, and we create a Simba instance, and we try to print it out. And this is like one of the first mistakes that new students have with C++. They try to print their custom type, but of course nothing is easy. So they have I think they usually get a few dozens of lines of compiler output. But since like a lot of you here are experienced, all of you of course know that the person should have of course implemented the operator less, which accepts the output stream and the const reference to a lion, and then we can customize the behavior of cout. Now we won't go into details what happened here. We'll do that a bit later. But this is an example of an ADL customization point. Basically, this operator less here, it kind of translates to the call that is commented out. Std operator less, which accepts the following arguments and later finds this particular implementation. As I said, we'll discuss a bit later how exactly does it work. Now, of course, everybody here knows that IO streams are not super good. So in C++23, we get the std print and println, which are basically based on the famous fmtlib. So now our new student tries to print their lion using the super cool new feature, but of course they still get a ton of compiler errors. The solution to that is, of course, you should specialize a class template. And of course, you should implement parse and format, and then you'll get the desired implementation. Now, this code, like when you see it the first time, it looks kind of scary, but this whole part is not important. The only part that's important are these two lines. We have what these two lines say is that we have a class template, which we specialize on the lion. And then we implement whatever is needed of us. As I said, these things we'll go over in a bit. So there are few things that are really important when you go into the whole rabbit hole of C++ customization points, And those are these two terms, which when I was first looking at this whole thing, I just glanced over them and I thought, yeah, nobody cares about whatever is a basis function or a customization algorithm. But my recommendation is that you should care, because like all of the wording is based on these two terms, and they aren't particularly complicated. Basically, when we have customizable functions, we could split them in two larger groups: the basis functions and the customization algorithms. The basis functions are the functions which have no default implementation, while the customization algorithm functions are the customizable functions which do have a default implementation, usually using the basis functions and whatever is available like from the language. This particular terminology first I found in the Eric Niebler's paper about tag invoke, which we speak about later, but it doesn't matter, you have links to it. So since nothing in C++ can be easy, we have multiple ways of doing the same thing. But of course, those ways have different characteristics. So I kind of wrote down a few of the main aspects on which we'll judge the actual solutions. So to go over them quickly, first off, we want to see what's the interface that needs to be customized. I think that's kind of obvious. Secondly, we want to have a mechanism for providing a default implementation, which can be overridden, basically to have an easy way to implement customization algorithms. Next, we want to have explicit opt-in into the customizations. We want to easily invoke them. And I remember the first time when I showed this to a friend, I know he mentioned that, like, how hard could it be to actually invoke something? You'll see. And the fifth thing isn't that important, but I still wrote it down, is that we want to, when we have some kind of generic function, we want to verify in compile time that the type implements the interface. So when you see all of like this 5 points, hopefully one of the things that comes to mind is the thing that probably everybody here learned at their university, and that's object-oriented programming. So let me just resize this. Now, this presentation will have a lot of code, and I will require a lot of your attention. So please try to follow as much as possible. And after every segment, we'll have like a mini Q&A break session. So since I didn't want to implement anything which was domain specific to whatever random domain I find interesting, I tried to do something which is so many times used that I personally am kind of sick when I see an animal in the OOP context or whatever, but let's just do it. Here we can see that our basis functions are hunger and is hungry. They are pure virtual functions. They have no default implementations. Then we have the customizable algorithms, eat and learn, which do have a default implementation and also have the virtual keyword. And of course, we have the normal / non-customizable functions. So first thing that I want to point out here is don't be concerned too much with the implementation. I know that this thing here looks super weird, that we are calling a function and then assigning something to it. But this was the minimal example that could work with all of the different customization mechanisms. So just have that in mind. So this is from the perspective of the library. Looks, I would say, pretty okay. But when we go to the user side, let's say that the user wants to implement a person, which is an animal, and they are required to implement the basis functions and optionally implement some of the customizable algorithms. The key things that you should see here is that we have first off, we have an explicit opt-in. We have to inherit the library interface, that is the class. And also we have the keyword override, which specifies that we're implementing a customization function. So based on my previous just a sec. I spoiled it a bit. Where is this? Okay. I'm not sure. Okay, this will work. So based on the following criteria that I laid out so far, it looks like OOP is the best solution, and that we should probably, just write that. But of course, there's a but. There's a problem with runtime performance. I won't go too much into it. There are a bunch of great talks on that topic. I know Ivica had something on virtual functions, so that's you can watch that talk. But basically, what we lose is the ability for the compiler to inline stuff. We have cache misses, blah blah blah, a lot of not so good stuff. I mean, if you don't care about performance, why are you writing it in C++? So runtime performance is something that we lose definitely. The next thing that we lose is also the non-intrusiveness. What I mean by that, when we have a class person T, and we want it to work with the library liblife, we have to, even though we have like an explicit way to inherit the interface, we still have to modify our type. And that's fine when we have our type and we can modify it. But when we have like two separate libraries which don't have a way to talk to each other, that's where it gets messy. And there is no non-intrusive way with inheritance to actually do that. And the final point is, yeah, sure. Okay, so let's say we have this library liblife. Okay, now if we had another library with their own type, and we wanted their type to work with liblife, they would have to implement it. We as a user couldn't do that. We would have to like fork or whatever we do. So there isn't like an easy way to do it. Yeah, thanks. And the namespacing thing, like in OOP, like in the virtual function case, there's like a few edge cases, but I'll say that there is no generic way to namespace the member functions. What I mean by that is I'll again like take the another library, libstudent, whatever, which has the interface iStudent, and let's say that iStudent also has member function learn. We don't have a generic way to actually specify whether we want to use the learn from the animal or from the student. Of course, that's if the person is at the same time an animal and the student, and those are two different things. Yeah.
We have the same method name in both of them.
Yeah.
We cannot.
That's the thing that I said. There is, I said kind of, because we can use the explicit scope specifier. Like, okay, I can actually do that. That's not a problem. Like I have the file here. So if we have like a lib student, and it also has like a, of course I'm making this up. So when we have the student Pera, I kind of jumped a few stuff here, but I'll get back to it. So we could kind of say lib life and then learn. But the problem with this is, let's say we have a generic algorithm. There is no way for the generic algorithm to know like what are all of the possible library implementations which could use the same name. So that's what I mean by namespacing. And that actually gets me to the rest of the implementation that I want to go over. Like the actual implementation of the functions doesn't matter. It's just something that I thought kind of made sense. So we have some kind of function which we want to accept every kind of animal. And in the object-oriented approach, we have a reference or a pointer to the base class. And we can say that you could, get good if you eat something healthy, learn, and sleep, and you do that a bunch of times. What happens here is we can also see that with OOP, we have like the really easy way to actually invoke our customized algorithm. The learn here will do the runtime dispatch, and from the vtable select the actual implementation that the person uses, because as you can see here, I created a person Pera, and pair is trying to get good. And when we call learn at runtime, it will dispatch to the correct implementation. So I basically said the same thing here, just to have it on the slides. It doesn't matter. Now, some questions, maybe like I expect this example to be familiar to everybody, but sure, like if there are any questions, I can take them now. Okay, great. So next thing are the class template specialization. We saw a bit of it previously. You can find it like most commonly, for example, in STL. If you have your custom type and you want to use it with like an ordered map or an ordered set, you have to specialize std hash. You actually have to specialize the class template for your custom type, and then it will work. But I think like the most famous example would probably be the fmtlib or std print or format, however it's called in 23. This was the example that I previously showed. So the same thing that I showed so far in the OOP case. Now I implemented the same thing, but with customization with the class template specialization. And I don't remember the alias I said, class template specialization. Yes. Okay. So now when we open the library, first thing that we can see is it looks super foreign. There is no apparent interface here. I'll just, in the slides, I'll jump to the actual conclusions so we can follow along. You can, of course, learn that when you use class template specialization and when you see a deleted default constructor, then you can assume that that's like a basis function. While if we have a customizable algorithm, we will implement the call operator, which will do the default thing that we wanted to do. And if you remember, I said like how hard it is to actually call something. Well, this is how hard it is. We have to, okay, we specify the thing we want. We have to specify the type. Then we instantiate it and then call and use the call operator, which isn't the prettiest thing ever and doesn't look like a function at all. Okay, these are also the customizable algorithms, while the normal stuff looks still kind of normal, except for the implementation. Now, when we look at the user, so this is, I personally think, super ugly. As the user of the library, we actually have to open up the namespace of the library, then do the class template specialization to implement the same thing which was previously implemented. Here I override the learn struct, or however, it's not a function, so function object. But I also want to use the default eat. So when we go to the getGood function, we of course have to template it, and when we have to call the customizable functions, we have to do the whole dance of passing the template, creating an instance, and then using the operator call. There is a way which can, like from the user side, make it a bit better, and I'll show that next. So we basically have the kind of the same library. Okay, so the only thing that I changed here is that I made the default template be void, and I did that for all of the stuff, basically all of the customizable functions. And the thing that changed is that I wrote like the default forwarder, which is already specialized on the void type, and then when the operator call is actually invoked, that's when it passes the template of the thing that we wanted to run. So maybe from like when you see it like this, it doesn't make much sense. But when we open it up for like from the user's perspective, it's still ugly. But now we don't have to pass the template itself. This is like a trick that is used by std-less, std-greater. You can just instantiate std-less, and it will, at call time, when the operator call is invoked, it will deduce the needed template. Yeah.
instantiate and then call a function, can you just use the static function for the same thing?
Okay, I'm not saying you can't because this is C++, but can you use a static function?
Actually, so you don't have to instantiate them.
Oh, okay, of course. The thing that's important. Okay, what you're saying is relying probably on ADL. Oh yeah, of course. I forgot to do it the first time. So the question is, why didn't I just make static functions, right?
So you have this handler class, and then you create an extension in an object of handler and call the operator. Why don't you have this operators static so you have to instantiate them? I think the compiler will delete this instruction. Probably,
because the mechanism that is okay, I forgot to repeat. So the question was, why didn't I make the static operator functions and then call them instead of doing the whole dance with creating an object and then using the operator call? Because the customization point that I'm trying to demonstrate here are the class template specialization. That's definitely possible, but that relies on another customization point, and that's ADL. When the user wants to specialize something that's like a free function, then we have to use ADL, and then it will do like overload resolution, and then it will select the best function. I'm not saying this is a good way to write stuff. I'm just trying to demonstrate the same example with few different customization points, and then you'll see ADL quickly. But this exact customization point is used with the fmtlib. And if you want your custom type to be easily printed, you have to do something pretty similar to this. So yeah, basically that's the reason.
Yeah. One thing we could have done is instead of potentially to remove object every time we have in library potentially to handler and just use the handler object.
Yeah. Yeah, and you're pretty close to customization point objects. I think you're familiar with it. So yeah, we'll get to it. And of course, I forgot to mention the question. So the question was, why don't we instantiate the objects themselves in the library, and they are like const expert and stuff. And when we use them, we don't have to. And when the user uses them, doesn't have to instantiate it every time. Yes, something like that will be shown in a few minutes. Okay. So, okay, we kind of did the questions now. Now, the next ADL. So this is the thing where stuff gets super messy. Argument-dependent lookup. Yeah. So argument-dependent lookup is a language feature which was designed to basically allow the same language to have both namespaces and also have non-member or free functions that are basically the public interface of a certain type. So I know this definition didn't maybe make too much sense, but in the example itself, we have some kind of library libcat, and it has a single cat which has a member function meow, and we have free function scratch. So since unlike Java, we actually can have free functions, and we can consider them to be the public interface of the cat. Okay, so what ADL was originally set out to solve is, like, let's say we instantiate the cat named Ollie somewhere in some other module, and when we do like Ollie.meow, we kind of already know and expect the call to seamlessly work. We know that it's its member function, so it should work. But what ADL enables us is to here write scratch. So I think you have to like pay super close attention. I wrote just scratch, not libcat : scratch. So I wrote just scratch and passed the argument Ollie, which is a cat from libcat, And the compiler managed to find the actual declaration, which is here in a namespace, even though I said just scratch. So this is like a high-level overview. We'll go into a few more details now, so hopefully it will make more sense. Okay, these are some like talks which you can look up, and also like this book for templates is probably, I think it's the best book for templates. I don't know if there's some other. So in order to understand argument-dependent lookup, we have to understand what is name lookup in general in the compiler. So whenever you write f of, let's say, 314, compiler goes through a phase called name lookup, where it tries to find all of the declarations which match the name f. It doesn't look at types, it doesn't look at anything, it just tries to find all of the declarations with that name. That's the name lookup. Then it returns an overload set, which in this case is, let's say, like this three declarations, which have different arguments. And then there's a phase of overload resolution, which does the hard stuff of selecting and choosing what is the best candidate, and at the end returning our f of double. That's the function which should be called, and this is determined every time at compile time whenever you call a function. So if you remember the name lookup thing, it was like a really small square. So when we zoom into the name lookup, it looks like it has a few more details. So first off, two terms which are super important, and I'll use them throughout the rest of the presentation, are qualified names and unqualified names. Whenever you say stud : sort or transform or whatever is prefixed with the scope resolution operator, which is the two colons, we call that a qualified name. And whenever you use just sort or transform, that's an unqualified name. And so in the name lookup phase, there are two kind of completely separate rules for looking up the names. For qualified name lookup, there's one thing, and let's say that the set of names that it finds is called Q. It returns that if we had a qualified name. If we had an unqualified name, there's still a bunch of rules which say whether we should do ADL or not. So I'm trying to explain ADL, but it's important to understand everything that happens before and after ADL, because so from this diagram, we can see that whenever we have an unqualified name, there's an unqualified name lookup. If we satisfy some rules, which I won't go over, at least not for now, we will call argument-dependent lookup, and as a result, we'll return the union of whatever argument-dependent lookup found and whatever the unqualified name lookup found. And then it's all passed to overload resolution, which does its thing. So an example, a bit more detailed now. We have first some kind of a global declaration of a scratch function, which is like for, like lotto and stuff like that. It's semantically completely different than the scratch, which is present with the cat stuff. Next, we have the library, which has a cat and has declaration for scratch, which accepts a single cat. And we have another namespace user, where they create the kitten, which inherits from libcat, and also implement their own scratch. So when in main, when we see just scratch, so back to the diagram, when we see just scratch, we know that this is an unqualified name. Therefore, we will use the unqualified name lookup. And trust me, we didn't violate any of the rules or whatever which would skip the ADL. So we would definitely go through ADL here. So what's the unqualified name lookup and ADL found? First off, the unqualified name lookup, that's basically the thing that you're already familiar with. Like if you're in this scope, you expect anything which is in a greater scope than yours to be found. That's kind of the default way of reasoning about stuff. So the unqualified name lookup, the only thing that it found, which was in the greater scope than the actual function call, was the declaration for this scratch with luck-based games or whatever. But then we go to the ADL step. In ADL, we managed to find both this declaration and this declaration. And the reason for that is essential to how ADL works. So ADL looks at every function parameter, looks at its type based on like kind of complicated rules of like for each different, whether it's a class, an enum, or whatever. There are like a few details, but here it doesn't matter. Here we have a single class. So for this instantiation, for this call of scratch, we will, because of ADL, look at the namespace, the associated namespace of this variable k. So the associated namespace for this variable is user. First, we'll find this declaration in the user namespace. But since kitten inherits from libcat, it will also get the one of the associated namespaces will be from the library, and also it will find this declaration. So to summarize, by unqualified name lookup, we just do like the normal search, you could say, but ADL does the really like funny thing that it can kind of bypass the namespaces and based on the type of the arguments, find the adequate declarations. So why does that matter? And what are the problems with ADL? So one of the problems that I expect most of you have seen at some point was the two-step ADL problem. Here we have some kind of monkey which has which is templated on a keyboard, and we don't know, we can't know the type of the keyboard until the template is instantiated. So what if the user somehow specialized the swap for the keyboard, for their specific keyboard, and they have like a more efficient way to do the swap? With this implementation here, we want to enable the monkey itself to be swapped, and the way it gets swapped is by swapping each of the members. When we have like a primitive type, we know that stud swap will do the best thing. There is no overload for that. But for the templated keyboard, we don't know whether stud swap is the most efficient thing. And here, how I wrote it, this is the qualified lookup. Therefore, when we have qualified lookup, there is no ADL. So this is a problem. The second thing we could try is to call it unqualified. And this will work sometimes. It will work whenever we have the specialized implementation, but it won't have any kind of fallback, which if you can think about it for a few minutes, basically you will have the specialization almost never, while you want the default thing almost all of the time. So the solution for this is the so-called ADL two-step. First, we have to do the ugly using stud swap, so we mustn't forget to actually do that, and then we do this the unqualified swap. If the keyboards have their own specialized swap, then it will call the specialized one. In the other case, it will just use the default one. When we do the using stud swap, that is found by the unqualified name lookup. So that goes to the use set that I previously mentioned, if somebody's like keeping track. Yeah.
That's the result is the compiler only put the swap in the test.
Yes.
And this, when I describe it like this, where does this using ends?
In the scope of in the current scope. Yeah, in the block-based scope. It's not for a function, but actually the scope. So I think if I'm 90% sure it's block scopes. Oh yeah, of course. The question was what is the scope of the using declaration, and I am 90% sure it's block scoped. So if we had like a nested if here and we had like curly braces, it would be only scoped there.
Question.
Yeah.
You know that if calculated standard library that you saw, for example,
Yeah.
as saw, would they call for custom implementation or will they be calling only as
So
you know,
I think they should have. I think they have to call they use the two-step thing in order for the like users type to be able to be specialized and be more efficient. I don't see any reason.
implement the swap for my custom type.
Yeah.
So do I need to put it in the STD namespace or I can put it in my namespace?
You can put it in your namespace. The reason for that, so the question was, so the first question was whether the STL uses this kind of two-step. I expect them to use it because like we'll get to another customization point which doesn't require that. But since STL is older than that, it almost definitely uses it. The second question was if I implement the swap for my type, do I have to put it in the STD namespace? And the answer for that is no. And the reason for that is exactly ADL. So when we just do an unqualified call to swap, it will first search using the unqualified name lookup all of the like greater scopes, and it probably won't find anything. Okay, but then it will look at the actual scope of your type, and in that scope, then there it will find the implementation, and that is exactly what I did here. We have a monkey, and we have a friend function swap. When ADL kicks in, as I said, there are different associated namespaces. When there's an unqualified name to swap and accepts two monkeys, it will in the unqualified it won't find anything, but in ADL it will go in the actual scope of the monkey, and it will find the implementation itself. Hopefully that kind of clears it up. We'll see it now with the previous example with liblife. So yeah. So the question was, should we specialize free functions from STL? Should we? Yeah, but we don't. Okay, we basically do the specialization, but we don't intrude into the. We shouldn't open up the STD namespace probably, but since we're trying to make our type swappable, you could say that we're specializing stud swap, but this is like ADL isn't tied to stud swap specifically. The only reason why it's tied to, sorry, it's not tied to stud, or the only reason why it's tied is because we're explicitly saying it here. If there is any other library which needs stuff to be specialized using ADL, we would do the same thing if we were using ADL as the customization point. But you probably shouldn't use ADL, at least like not the default thing. Some people also call it plain old ADL, and there's a reason for it. So you'll see quickly. So now, when we open up the implementation using ADL, I want you to ignore completely the concept. I'll get back to it. But when we look at the functions that we previously wanted to implement, we're finally back to functions. We don't have some kind of function object. We have actual free functions, and they are readable. But what's the problem? What's the first problem with ADL is that without concepts, there isn't an easy way to actually specify what are the basis functions. Here I created the iAnimal concept, which requires the template, the type T, to be callable with hunger and is hungry. Now, this is a feature that is orthogonal to ADL. So that's the reason why I said that ADL does not have an easy way to identify the interface. And before you think that, oh, why didn't I just put eat or learn, because those are customization algorithms, there is no way for me to put it in the same concept, because here I want to implement the concept with that interface, and that would create like a recursive definition. So the only thing we can put in the concept are the basis functions, which are used in our library. Default implementation works here pretty okay. Now, when we go to the user side, what we have here is, so we have a person T, and it implements the functions with the same name. Here I'm using something which is called the hidden friend idiom. It helps with compile time, and that's completely unrelated to my talk here. Basically, just if somebody is super interested in it, like whenever we are doing the name lookup, if this name hunger was a free function here declared in the global space, every time somebody calls hunger, it will be included. But whenever we put it here as a friend of this class, it will be only found by ADL. So because the overload resolution algorithm is quadratic, and we don't want our compile times to take forever, we want to minimize the number of visible functions. But this is like completely not important. It's just a kind of a fun fact. But from the perspective of the user, we are creating the basis functions. We have to implement them here. And
sorry,
yeah, sure.
This friend modifier, without it, this function will need to be outside.
Yes. Yes. So the question was, if we deleted the friend modifier, whether we would have to put this function outside of the class, and the answer to that was yes. I'm doing completely the same thing which I did previously. I'm implementing the basis functions and overriding a single customization algorithm. And when we look at our getGood function, this is the first place where we see the ugly side of ADL. So we have to, if we want ADL to kick in, and I point you back to the diagram that I showed about qualified and unqualified names. If we want ADL to kick in, we have to call the functions with an unqualified name. We couldn't say liblife eat, because if we did that, it would call only the default implementation and not the potentially overridden one. And the thing we have to do here is the so-called two-step, where we say using liblife eat and liblife learn, and do an unqualified call. And if the type which gets passed as a template, and have in mind that this is a concept that's constraining this template, if that specific type implements in the way that I showed previously, then it will call the specialized implementation. Else it will fall back to the default one. Now, as you can see, like this relies only on on the compiler figuring out which functions should be called. So the runtime performance here is pretty good. It's completely non-intrusive, since we can add the here I added them as a friend as friend functions, but we could have completely never opened up the actual class and just added them as free functions in the scope above. The number one problem, and that's like a super big problem with ADL, is namespacing. If we have two different libraries that have the same name for their customization point, there is no way for us to use them at the same time for the same type, because we have to do an unqualified call, and that unqualified call has to result in either the default implementation from one of the libraries or the specialized implementation. So we'll see a few solutions which try to tackle that. So just a quick recap. Where are we so far? It looks like we're trying to get somewhere, but it just keeps getting worse. So it looks like OOP is doing pretty good. Like virtual functions have a lot of stuff except for performance, and also like personally it pains me the lack of value semantics, but that's another topic. They are simple. Yeah, I agree. So with ADL, the thing that we got was that we could easily call the default implementation. That's basically the only thing. But ADL is actually the mechanism on which the two remaining customization points are completely based off of. So, okay, questions?
Can you go back to the iAnimal?
Oh, yeah, sure. Just a sec. Yep.
These are unqualified. Call them calls. Whatever.
Yeah, unqualified names.
Yeah, unqualified names. So how does compiler finds like default fallback implementation? Let's say it was not counter. Let's say it was swap.
Okay.
And if we didn't provide swap for our type and we want to fall back to STD swap, how does compiler in this case?
So if I have to repeat the question, I'll try my best. Okay, please interrupt me if I didn't understand it correctly. Like the question was, why didn't we put, for example, something with a default implementation here, and how does a compiler find the default implementation since we do the unqualified calls?
Yeah.
So that's something that I maybe glossed over, was this comment. There is no way for us to specify that in the concept for customizable algorithms. Customizable algorithms are the customization functions which do have a default implementation. Here, hunger and isHungry are the basis functions, the basis like in vector basis. So their combination is used to generate all of the other customizable functions. We know by definition that they don't have a default implementation. Therefore, we require the user themselves to actually implement it. Okay.
This is something like we have
Yeah. So the question was, or the comment is, this is kind of similar with the OOP case when we had a pure virtual function. Yes. That's why the reason why I defined the basis functions and customization algorithms is because that's like a more maybe general term, but you can look at the basis functions as the pure virtual, while the customization algorithm as just virtual with a default implementation. That was the main idea of showing you the OOP case. Okay, we went through questions. So this is something that we kind of alluded to throughout the presentation. The customization point objects, or I'll call them CPOs because this is like a mouthful. CPOs, unlike all of the previous solutions, is a library-based solution. So this uses ADL under the hood, but it's actually a library-based solution, and it's super ugly, but you'll see. Some people also call it Nibloids, which isn't really correct, but it's kind of the same thing, but it's more of a standard naming thing. It doesn't really matter. If you see the term Nibloid, it's kind of the same thing. So where CPOs are mostly used is the stud ranges or range v3 library. And the main things that it provides is that it first fixes the ADL two-step. We don't have to do the whole dance. It will do it for us. Then it gives us like a few maybe extra things that the previous customization points didn't give us, and that's that it makes the overload set a first-class citizen. We'll see in a moment what that means, and also richer dispatch. As I said, we'll see it with examples. So with the fixing the ADL two-step, whenever you implement, for example, swap on your custom class, if you use stud ranges swap, it will just do the right thing. You don't have to listen to me talk about CPOs at all. You just use stud ranges swap, and it will do the correct thing. The way it does that, we'll find out in a bit. One also thing that I want to note is, since we have the banana count is an integer, there is no specialized implementation that could be found by ADL for integers. So for the banana count, I could have used stud swap and it would do the exactly same thing. But for the generic case where or anything which is a class, then I want to have a way to use the more specialized implementation. And for that, stud ranges swap is super nice.
Just a question.
Yeah.
Why is swap the ranges? How does it play?
Why is swap in stud ranges? So, okay, so that's not like yeah. No. This runs. This ships like I ran everything before. So because the implementation is completely different. So okay, first off, backwards compatibility. You can't break the behavior of previous code. So the only way you could add another function which was called swap was to put it in a separate namespace. So that kind of answers the question, why is there stud ranges swap? There is basically for I think there was a talk a few months ago about ranges. Whenever you have like some algorithm in STL, which usually accepts like a begin and end iterator, the ranges give you just a bit nicer interface where you can just pass the whole thing and it will do the begin and end for you. So my point was that their swap isn't the only one. Basically, everything in STL is duplicated.
Yes, but okay, I understand STD range is sort, or STD range is a begin or whatever, but swap is like it's.
Yeah, but here there is a there is a difference, and not only in implementation. Of course, there's a difference in implementation, but there's a difference in behavior. That's the key thing. Like this, you can't just go in your code, just find and replace every stud swap with stud ranges swap. I mean, you probably can. Okay, that's not a fair characterization. You couldn't do the reverse, but still. You'll see why is it different. Just give me a few minutes. I mentioned that CPOs enable us to have overload sets as first-class citizens. So this is something that I remember I was super annoyed with whenever I tried to use only algorithms and just write stuff in this generic kind of functional way, whatever. Whenever I wanted to pass something like stud min or stud max, it just wouldn't work. The reason why we can do the call here, so we have a vector of unsigned numbers, and we want to find the maximal one using stud reduce. Stud reduce isn't important here. The important thing is the thing that we're passing here, stud ranges max. Previously, what you had to do was create kind of a lambda, which will itself call the max, and that would work. But that is like super annoying to type every time. The reason why this works is because the stud ranges max is actually a function object. If you remember function objects like from the class template specialization, a function object is a class which has an implemented operator call. So we'll see the implementation of CPOs. But the reason why we can pass them as first-class citizens is because they're objects which have the operator call implemented. And also one thing which is super nice is that, okay, even though they're function objects or whatever, we can call them qualified as we did in the previous example, stud ranges colon swap, and that would do the qualified name lookup, find the object that implements this whole thing, the CPO. But the nice thing is that we can actually do the unqualified call as well. If in some scope we say using stud ranges swap and then do an unqualified call, even though this is an unqualified call, if you remember, I said there are some kind of tricky rules which say when ADL does not kick in. Whenever we have something which is a function object, ADL does not kick in. So these 2 lines and this line here are completely identical, and we have exactly the same behavior. So stud ranges swap is like by definition a better implementation than a stud swap for basically every case. I am sure somebody can think some kind of edge case. Yeah.
Basically having kind of swap ADL completely in the scope in which you will introduce.
Yeah. So the question was whether having something as a function object will suppress ADL, and the answer to that is yes. And that's the reason why they did this. This was originally implemented by Eric Niebler when he was working on the ranges v3 library, and like he saw that it's super hard to actually define customization points which work in an expected way. So what he did was basically make every call go to a single place, which is the function object, and the function object itself is the one who will do the ADL for you. We'll see it in a few seconds. I just wanted to show you this first before we go over the implementation. So this thing, the whole thing that I'll show you in like a minute, we do the whole thing just for the easy invocation. Like we have everything the same as the plain old ADL, but we can easily invoke it, and we get a few benefits with the first-class citizen stuff, and that's super nice. But still, when you see the implementation, I don't know, I wasn't a fan of it. CPU. Okay. So if you have waters, now is the time you should drink a bit. We have the same familiar concept, blah blah blah. That's not important. Now, what we have to do in order to get this to work? First, we have to first open a separate namespace. It's common to call it detail or something. And for each of the customizable functions, that is the basis ones and the customization algorithms, we create this struct with an operator call, which just does the right thing and calls the default implementation. Since these are basis functions, there is nothing to call because they have no default implementation by definition. Now with customizable algorithms, in the call operator, it calls it, but it will pick up the default implementation. When the operator call is used, ADL will find it, or in this case, okay, the specifics aren't that important. The same thing for learn. We have to do if you open up documentation for ranges v3, you'll see a lot of name of the algorithm _ FN. What I'm showing you here is basically that. And for the extra ugly part is that we need this thing here. We need an inline namespace of function objects, which have an inline constexpr instantiation of the actual types. And the key thing is that we call them the same. Okay, I didn't want to do this. The inline keyword basically saves us from the one definition rule, which would complain if we didn't have the inline keyword. Because I put stuff in the detail namespace, it wouldn't clash, but there are implementations which also have to do some other trickery to make this work. But I don't think this is like a normal way to write code. Like this isn't something that people should do, but yeah, people do it. Yeah, of course you can hide it behind a macro. The things that I didn't show here, and which is super annoying with CPOs, is these are like baby CPOs, because if you want to do anything generic, you would have to create separate concepts that would forward no except. You would have to create separate concepts which would check whether the thing that you passed is actually callable with the function. So what I showed here is the nice version of CPOs. Whenever you look up like real world implementations, they're even worse. We'll see with tag invoke how real world can look like. So from the perspective of the user, this is the cool part. From the perspective of the user, they do the same thing they did with ADL. So the user doesn't know whether the library does a CPO, tag invoke, whatever. The user only knows it somehow uses ADL, and it can they can provide the implementation which is needed. The thing that we solved here is that we have basically now qualified calls, and the first feature that CPO solved is the actual namespacing problem. Because if you remember, when I talked about ADL, I said that we need to have an unqualified call, which would later, deduce to the adequate function. But here we have our namespaces back. So did I do this correctly? Okay, I think I lied here. Just a sec. Yes, no, I think I lied here completely. And the reason for that is because ADL will pick it up. Yeah, sorry, I completely lied this part about namespaces. Yeah, we can do a qualified call. We don't have the two-step anymore, but actually, okay, I have to go back. Okay, I apologize if I basically confused somebody right now. So even though we have a qualified call here, which is fine, the reason why we still have the namespacing problem is here. The person, which is the user, which is specializing their type, they cannot differentiate between learn, which is from liblife, or learn, which is from libstudent. So we still have the namespacing problem. I jumped ahead a bit. Okay, so I apologize once again for the confusion. Do you have? Okay.
Yeah. On the phone side, we don't have a problem, but
yep.
On the implementation of the customization,
yeah.
You got a problem. But for the people and what you can do is, so you have lib/it, but the actual customization that you delegate to is not it, but is lib or something. And if you do that way,
that's like.
So we have solved it, but it wouldn't be really nice.
Yeah, that's like basically introducing the C way of doing namespaces.
Yeah.
Yeah.
So that's the name of the function that on the implementation side. Yeah. So the order of what still writes. Yeah. Yeah. The implementer is right. The C name.
I think okay, so the non-intrusiveness is the ability, or like the ability for the user, which is implementing some behavior from the customization point of a library. It's the ability of them for the user to do that without going into the type and having an access to the actual like the implementation of the type. Here, what I showed was putting stuff as friend, as like hidden friends, but you could have used like free functions, and that's an example where when you have two different libraries and you don't have an access to the actual implementation of a type from a second library, and you want to make it work with your library. You can use ADL in order to basically customize and enable the type from a separate library to work with your library. Does that answer the question? Okay, the question was what was non-intrusiveness.
So you can implement the logging function for that third-party library.
Yeah. The comment was that the great example is when we have two libraries. One is a logging library, and you want to log something from the other library. you can use ADL to specialize it. So the final example is tag invoke. Tag invoke is also based on ADL. So it's also a library solution. You can find it in libunifex, and also there's like a standalone duck invoke implementation. So tag invoke is the one that actually fixes the namespacing problem. I jumped a bit ahead when I talked about CPOs. Instead of having a CPO for every customization point, the idea here is to have one single customization point, and we call it tag invoke. And we only reserve one global name, because maybe I didn't emphasize it enough with CPOs or anything which is based on ADL, which is in tag invoke. We have a problem where whenever we decide, okay, this is the name of our customization point, basically we decide for the whole space, for the whole design space. Like you can't have like anything which is named begin. I mean, you can, but you risk that your type possibly could be interpreted as a range, which maybe it isn't. So that's like a super big problem. And that's the reason why people don't call stuff begin and data size. Those are all of the CPOs which are available now in STL. I think there's about 30 of them, something like that. So not only you can't use like, if or for the name of your variables, you also can't use anything which is basically something like super general. And as I said, that's like a super problem. So tag invoke is, I forgot the authors. I know Eric Niebler is one of them, and two other guys. So tag invoke was tried to solve everything, tried to solve the namespacing problem with CPOs and kind of improve them. So first I'll show you this table. Tag invoke looks kind of okay. It's still not obvious what is the interface, but as you'll see from the implementation, it kind of, I mean, not the implementation of the library. From the user side, it looks better. Okay, I'll skip this to the user. So don't be frightened by what you see now. It's actually not that hard, and this is like the #1 like C++ Stockholm syndrome, but I think it's actually okay. So whenever you see this is fine, yeah. So whenever you see tag invoke, you know that that's a specialization, that's a customization. Like that's something that needs to be customized. And whenever you see this, you should basically just look for the first argument, and that's the name of your function. Like something which, okay, something, yeah. So something which you would probably, if you're normal, named hunger. If you're not that normal, you should use tag invoke, and as a first argument, pass something like this. So as I said, like this is a bit uglier on the user side, but what it does is based on like tag dispatching, or if you're familiar like with phantom types and stuff like that, like as we explained how ADL works, and then the overload resolution. Whenever we call our user side function, it will resolve based on this arguments. Like, okay, I didn't explain this well. If we had a function in the previous example with the f and like the name lookup thing, that function accepted only a single double. When we do the lookup, we will find a few different names with f. But when we do overload resolution, we will find the best match. And we found the f of double. The same is here. The first argument, I didn't give it a name, but this could be whatever. So that's the reason why I left it out. But this libtag tag t blah blah blah, that's the name of our first argument. So whenever we do the tag invoke, it will match the actual arguments, and it will always call the correct thing. So let's look at the actual usage. Yep.
Can we move that the end department at least, and then assign the default?
It has to be fixed. So because of the implementation, it has to be fixed. It's easy. It's easiest to do it on the first, but
sometimes
yeah, I'm not saying somebody couldn't, figure out something with some template magic, but like this is the most straightforward thing to do. Just put it as the first argument, and everything else goes later. So this is kind of semi-ugly from the user implementation side, but from the user usage side, it's pretty okay. I mean, it's not pretty okay, it's great. Nobody knows that we're actually using tag invoke or whatever magic. We just know that I just want to call my liblife eat, and it will 100% call the correct thing. There is no way for it to call the eat from some other library because of the way tag invoke works. So now you should prepare yourselves for the library. Yeah. Yeah, this could be put behind a macro. I have seen different implementations of it. I actually tried something, but then I didn't have the time to mess with the variadic with the packs and stuff. So I just wrote it out by foot. So what we have here for the basis functions. Okay, we have the inline const expert, blah, 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 blah. And the good thing was, if you remember with CPOs, I said that I showed you baby CPOs because for each CPO, you would need to write at least 2 separate concepts. What tag invoke enables you is to actually all of that complexity with tag invoke, you just put it in some separate library. You have maybe one person who understands it, and everybody else is sort of happy. And all of the implementations do kind of the same thing. You just give it a name here, and you just call tag invoke, and the first parameter you pass is this, or actually the actual object. So this is for the basis functions. For the customizable algorithm, it still is kind of ugly, but as somebody mentioned, this could be probably made better with macros and stuff. But the only thing we did here was just add the tag invoke, where the first argument is the type on which we're basically trying to do overload resolution and match that type, and all the rest of parameters. I see I have a error here with forwarding stuff, but it doesn't matter. That's for the customizable algorithms, and for the normal stuff, it's still normal. So this could be made better. The implementation for tag invoke, I basically went through the original paper, maybe renamed a few things. But this is the hell we're actually trying to hide away. I honestly don't want to even try. I mean, it's not that bad. It is bad. It's not bad because I've seen this code for like the 100th time, and now I'm okay with it. But I think we as an industry shouldn't accept this as code, but it is what it is. Yeah. So the important thing here is that if you remember with CPOs, we had like each CPO for each customization point. But here we have the whole, inline namespace dance only with tag invoke, and we just have a single global name which is reserved, and that is tag invoke, and everything else just uses that to implement their stuff. Like here, you can just see some, helper concepts which could possibly help with the actual implementation. And yeah, that was tag invoke. And that's the best thing we have. Like right now, this is the best customization mechanism available for C++.
It's really
Yes. Yes.
And I think if we get that, maybe we should.
I agree. Can you do this? Yes. Duck in. I mean, you can do enable if till you die, but I don't know. I don't want to write that. I know the duck invoke library is actually a C++ 11 compatible tag invoke implementation. So you could just dump it on somebody else to implement it and just use it. But I haven't personally used the duck invoke. I just saw it used.
When you have another library that happens to have tag invoke, but
What?
use it in a different way.
That,
end up in the same situation, so suddenly.
if you have two different. Okay, I don't have an answer like from my experience, but from experience from more experienced people, and what I saw from like their papers and talks, there are currently multiple libraries which use different implementations and make it work, but I don't have like personal experience I can share. Yes, you just call it. Yeah. That's actually the most correct answer. When you use a library, you don't know you're using tag invoke under the hood. You only know if you're the one that's trying to specialize something for your type. If you open the library's header, probably. I mean, when I open the liblife, just a sec, you see tag invoke a lot of times. So there is no way for you to miss it. Yeah.
I would probably need like for each of my methods a few hours of training just to get familiar with this. Oh, that's not it's for me. This is like nobody needs to know, right?
You just hide it behind a macro, like from the library definition standpoint. But for the users, it's the same thing as ADL. Like we have a friend functions. Okay, it's not the same. We have the tag invoke here, but oh yeah. So the question was, and actually the remark was that this is like super hard to teach, and somebody else said that it isn't that hard, like from actual experience. I think, like, especially from the user side, you just say to them that you don't look for the name of the function here. You just look here. And I also saw, so one of the talks, I'm not sure if I put it on the slides, but one of the talks which goes like even in more depth about tag invoke was by Gaspar Rajman. And he actually said that like they kind of created how do you call it, like an idiom in the company. Like you don't use the libtag t thing, because even though like libtag t isn't anything super smart, that's like a decay of decal type. I mean, it's not something super interesting, but you could, like, the tag t of liblife hunger is exactly the same as writing liblife hunger fn. So if the first thing makes more sense for the actual implementers, maybe you can use it like this. But this is like a more, maybe from like software design perspective, less coupled way of doing it. You don't have to know the name of the actual type. You just know the name of your customization. But that's a trade-off at the end.
Are there any additional benefits?
Yes. And honestly, so the question was, are there any additional benefits? There are additional benefits when you want to get like super crazy and want to have a general way of customizing the customization points. Like, honestly, I looked at the paper for a few times and I'm not still sure I get it 100%. but what it enables is basically an easy way for you to decorate the actual customization points. Like if you want to have, let's say you have some function which returns int. If you the customization point returns an int, if you want to basically decorate it so that it returns an optional int, there's a library way to easily, like you write it once, that will enable any customization point to be actually like decorated as to return an optional value. I first thought to put it in the slides and everything, but I think like this is enough to be honest of complexity. But yeah, definitely, I think I mentioned it in the slides. Oh yeah, I actually put the link. Generic decoration is enabled by tag invoke, and you can see the implementation of it and a lot of stuff that I covered today also in Gaspar's talk. But have in mind that like he goes fast and into a lot of details. So I watched the talk a few times and then I kind of understood what he was saying, but I don't think that's an easy talk to familiarize yourself with the whole topic.
Yes. The only thing that print is identify. Can we once again go to what identity means that be aware of.
Okay, sure. So the question was, since tag invoke solves almost everything, and it doesn't solve the identifying the interface part, we should define the identifying the interface. The identifying the interface, I would say, is more of a philosophical aspect than a directly measurable thing. The identifying the interface means when you open up code, can you see vividly, okay, this is a thing which is customizable. With OOP, you have that is virtual functions. You have the keyword virtual, and when you see virtual, you know, okay, this is customizable. When you see virtual blah 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 equals 0, you have a pure virtual. Okay, this is a basis function. That is a more of a syntactic feature than like a hard semantic one, and because of that, there are customization functions. This is a proposal which is for C++ 26. The idea is to have the same semantics of tag invoke, like all of the things that I showed you, like the way it works, but without the ugly parts. Like the syntax itself is actually, humane and readable. So let me open it up. What's the name of it? Nope. Okay, I don't remember the JSON functions. Web live. So, well, oh, there's a question. Okay, just a sec. Okay, yeah, the question. Oh yeah. Actually, that's an important part I glossed over. Yeah, you're actually correct. So to quote Gaspar, you should just ignore the first 2 template instantiation. The third one is the thing that you missed. So I mean, yeah, that's not good. Definitely, especially teaching that. But also, you could say the same thing, like for the plain old ADL. In one of the first examples, when I try to print a lion, when you don't have the operator less. Okay, maybe now compilers have specialized support for that specific case. But in general, it will just dump on you a giant overload set and be like, okay, I couldn't figure out which one of these 70 functions you wanted to call. So I wouldn't say, yeah, it's definitely not a good thing. But still, a lot of stuff in C++ already has horrible compile time messages. The same is for, what's the name? The class template specialization. That's still, if you hide it behind, as I did, the delegation for the void, the void specialization, and you have to jump through hoops to find your actual error. I actually, now that you mentioned that, there's a super good paper about this whole thing from Barry Revzin, and he goes through like similarly as I did in this presentation. He goes through all of the different customization mechanisms, and he mentioned like maybe I can pull it up after we stop recording. He like tried to implement some range, something, and the error was on the 154th line after he like expanded the actual depth of the compiler output. So yeah, it can get pretty bad. But are there any more questions? Yeah. Yeah. Yeah, the thing which is open right now. So the question was, are there any language level initiatives for this to be fixed? And the answer for that is definitely. Like tag invoke was actually proposed to be added to the standard library, but it didn't at the end. I'm sorry, did somebody say anything? Okay. And now this is like the latest proposal, I think, is from maybe September last year. Originally, this customization function stuff was proposed in 2018 with different syntax. The guy who proposed it wanted to use the keyword virtual. Here, it's the keyword customizable, and people didn't like literally the syntax of virtual. But from the papers I've read, there's like an unanimous agreement in the standards committee that this is something that needs to be fixed. The number one reason why this needs to be fixed are executors. So, okay, now this is like a tangent. It's not completely related to this talk, but basically, executors have been like rewritten at least, as far as I know, at least 2 times. First time they were written like with CPOs, then they rewritten it with tag invoke, and now they're like, okay, let's not add tag invoke to the whole library and make the whole ecosystem suffer. Let's add language level feature, which will do the stuff that we want to do, and which is actually nice. And I don't want to go on a whole rant about the standards committee and stuff, but basically this is the latest we have. Is this proposal, which was revived by Quentin Jabot, I don't know how his name is pronounced, Gasper, and one other person whose name I forgot. But basically, the 3 of them are working on this proposal. Yeah. Actually, as far as I understand, no. There's a new proposal also by the same guy, Gasper. That's like the take 17 for the unicorn function syntax. But I don't know, like he wrote the paper. It's still not accepted or anything. But I think no, because as far as I understand, unicorn or universal function call syntax, its purpose is to enable for us to call the same way like the member functions and the free functions. Maybe I'm mistaken, like somebody could correct me on that. But yeah, I as far as I know, those 2 proposals are kind of orthogonal. Yeah, question?
Yeah, so object-oriented this purpose to prioritize parameters passed to the functions as first parameter is the most important part. That parameter you choose what to do.
Okay. So I'm sorry, let me just repeat it for the recording. So the comment was that OOP taught us that the first argument is the most important one, based on which we choose what to do. Yeah, please continue.
And basically, we have something that don't fit into that. Those are like swap, where we have parameters of the same type. But what happens when we have functions that have n times different of same importance? Basically, how to do implement customization.
Okay.
To I want to implement one configuration. Mine argument, mine type, second one, your function. And yes, it's possible to actually implement the customization when you have function. Let's say you can deal with
Okay.
Yeah, but the problem is not problem. Like, so sure, we're talking here about mechanism customer. We have to write the actual condition coverage. Like, what should be the guiding place where you write? So you have three arguments, same importance. Like, we write in the first place, second place.
I'm not going to repeat that, honestly. Sorry, like, there was too much discussion. Like, I'm not 100% sure. I understand what you're saying. Like, we have a function with different types which are of the same importance, but there is no like.
Basically, example, when you have a serialized, for example.
Yeah.
You have an object with serialized, the place with serialized food.
Okay.
Where to put those I want to specialize for my type. This serialized and to specialize for my type to set serialized data.
Okay.
And where to implement the
okay, that's a really cool question. I mean, I'm sorry, could you repeat? Or you can just model the problem differently, like a variant or something. But I think that's more of a design question, yeah. Than
and want to customize and so you can serialize the data, then serialize the model. And then you have your read. The read buffer can be a vector or a string, right? So you put into the data model, all those data in the same module where you have the type, or in the JSON module for the basic one and the YAML module for the YAML. Right? Like if you have a bunch of types and a bunch of operations, if you do the virtual, every time you do a new type, you must be in a different operation. And if you do the visitor, then you have the other way around. Every time you implement a new operation, you have to visit every time.
Yeah, that's the expression problem, basically. Like what you're describing in type theory is called, or language theory is actually the expression problem. Usually some languages choose, like in C++, we have the two different solutions. Like the OOP solution that you mentioned is the visitor pattern. We could completely like flip the problem and model it in a different way, like with some types, or in C++, what we call a variant. But at the end, I think that's more of like a discussion of, how do you design software and not something that's super tied to the customization points. Yeah, I mean, I agree, but still, I think it's like a small part, while the whole design is something, much bigger. Let's just go over like through the code. I don't want to keep you for 3 hours. Basically, the proposal says that instead of the whole mess we had with tag invoke, for the basis functions, we would just add this like keyword customizable. They use the British spelling. And for the customizable algorithms, we just add the keyword default when we won't have the default implementation. Bear in mind that this syntax isn't like something that's super fixed. I saw, of course, on Twitter that some of the like people who are working on the paper itself were discussing maybe making it possible to have both customizable and default, so you don't have to write like twice the whole thing here. So this is probably going to change. And yeah, from the user side, it's okay. LSP. It's kind of still the same. But we don't have the ugly tag invoke thing looking for the first argument, blah, blah, blah. We just look at the name. And an additional thing which is nice is that we have the keyword override, which also specifies for us that this is something which is customizable. From the usage perspective, same stuff as with tag invoke. We don't know the actual mechanism that we're using. So basically, customization functions do all of the things that we want them. Also, I just wanted to comment that I put the verifying type interface, I put a check mark, but honestly, I'm not sure if I should put it here, just because when I tried reading the paper, it was like full of the standards committee language and terms. So I'm not 100% sure that this is like the verifying type interface thing is like at this point done, but the actual people that are writing the proposal say that it is. So trust them, I guess. So yeah, I showed you the customization functions. Thank you all. I think we did all the questions. So yeah, I'll let Goran speak if you want something to say. Yeah. Okay. Well, thank you all for coming. This has been a blast. Oh, there was a question. Oh, yeah, sure. Of course not. Okay, I can now reference. Oh yeah. So the question was, did I try to benchmark this? Based on what I've read and what I've seen from different talks. And yeah, I also want to mention this. There isn't a lot of information on this topic. There are basically two talks. One is from Gasper. I think I left the link already. The other one was recently given by Inbal Levy at CPP Now last year. So those are the only two talks I know that are like, overviewing all of the customization point stuff. And there are a lot of papers. I left references to them. Okay, well, the question was, yeah, the benchmark thing. So what I've read and heard is that with tag invoke, the compile time gets a bit worse. I mean, of course, because you're having like 3 extra template contexts, and yeah, there's a bunch of stuff which is happening under the hood. So the compile times do suffer, and maybe that's something that I should have put in the as one of the features that we're testing, different implementations on. But if the customizable functions do pass the actual committee test, then we would have directly a language feature, which wouldn't need the whole instantiating 6 templates in order to get something useful. So yeah, I don't have any concrete benchmarks, but that's kind of, people usually say that the tag invoke from the performance perspective, of course, is as good as it gets since it's compile time. Yeah. Of course, ranges uses the CPOs that I talked about, and you definitely suffer from like compile time, and also the errors aren't super great.
That part would be one fact, because all new compilers develop this same type of application that is devirtualized. If they approve at the call site, if you didn't go to virtual dispatch, see that benchmark, because it's a lot of fun. It's a lot of work.
So if I understand correctly, because of link time optimization, the devirtualization could be applied, and sometimes you can like not have to do the whole vtable thing. Are you saying that? Yes. Okay, sure. But as far as I know, yeah, that's the thing I want to say. So just like a small comment on that is that basically, okay, there are some kind of optimizations where the compiler can deduce that something can be, devirtualized and everything, but I think like the problem itself is inherent, like it's inherently slow because you have a pointer to some memory which will be deduced only in runtime. So yeah, you can try some interesting tricks, but at the end of the day, the problem itself, the modeling of the problem itself is inherently complex and it needs to be like determined at runtime. So yeah. Yep.
The old version where you're just doing the runtime dispatch of object of inheritance approach is not only concept, right?
Yeah. I mentioned that for I mentioned that for a second, for a brief second. Basically, okay, you do lose some performance, but you also lose one of the things that I personally think makes C++ nice, and that's the value semantics and the reasoning you can have when you have types which like work that way and not have to pass like unique pointers or pointers for everything. So the performance isn't the only trade-off.
Yeah. Enough template method programming with OOP method, you will still resolve those problems within space and stuff, I guess.
Well, I mean, I'm not sure. Yeah, you could templatize, but I don't think. I'm pretty certain you can have a template on a virtual function. I think that doesn't work. Yeah. Okay, we have to wrap it up. Yeah. Okay. So once again, thanks everybody for coming, and for the online people, thanks for joining. Yeah, thank you.